Good day everyone. For today's discussion, let's try to solve problem from correlation, linear regression, and hypothesis testing. First problem is the given is from x variable 3, 4, 5, 6, 7, 8 and y is 6, 8, 9, 12, 15, 16. So let's make a table indicating the value of x and y. The third one is xy, which we multiply the value of x and the value of y. So 3 times 6 is equal to 18. 4 times 8, 32. 5 times 9, 45, and so on. The fourth table is x squared, which the x table we're gonna square it. So the square root of 3, 9, square root of 4, 16, and so on. And the last column is y squared, which we're gonna square the value of y. 6 times 6, 36, 8 times 8, 64, and so on. After getting these numbers, we sum up each column. From here to here, we're gonna add up for us to get the summation of x. So 3 plus 4 plus 5 plus 6 plus 3 plus 8, 33. 6 plus 8 plus 9 plus 12 plus 15 plus 16, 66. Is equal to 400. And x squared, summation of x squared is 199. The summation of y squared is 806. After getting this value, why we get this value is because it is needed here in our formula. After getting that value, we can now solve the formula, which is r is equal to n summation of xy minus the summation of x times the summation of y divided by the square root of n times the summation of x squared minus the summation of x squared times n times the summation of y squared minus the summation of y then squared. So let's substitute the value. So n is 6 because we have 6 given value. 400 the summation of xy, this one, minus the summation of x, which is 33, times the summation of y, 66. After that, divided by square root of the n sample value is, which is 6, multiplied by the summation of x squared, which is 199, minus so on. We substitute the value and then we solve it. 6 times 1, solve until we get the value of correlation, which is equal to plus 1.011. So this is the value of correlation r. So the second problem is about hypothesis testing. So the problem is, a researcher reports that the average salary of a college teacher is more than 65,000. A sample of 45 college teachers has a mean salary of 67,900. At 0.01 test, the claim that the teachers earn more than 65,000 a month. The standard deviation of that population is 5,350. So we have here the given are the mean is 67,900 is the mean of the salary, while the population is 65,000. Then the standard deviation of the population is 5,350, and and the sample is 45 college teachers. So the solution is step 1 is to state the hypothesis and identify the claim. So the population is less than or equal to 65,000 or greater than 65,000. So step 2, the level of significance is which is given 0.01. The critical value is positive 2.326. After getting that one, we solve the value for z. So the formula of z is equal to the mean minus the population over the standard deviation of a population divided by the square root of the sample population. So by that formula, let's substitute the value. The value of mean, which is 67,900, minus the population is 65,000, divided by 5,250, which is our standard deviation of the population, divided by square root of sample, which is 45. Saya po sulat. Saya po sulat. So 2,900 minus divided by 845.909274095 is equal to 3.4282. So our decision is ang 3.4282 is nadari siya, while atong critical value is 2.326. It's covered man siya, so atong i-reject ang null hypothesis. So atong last conclusion, since we reject the null hypothesis, we can conclude that there is enough evidence to support the claim that the monthly salary of college teachers is more than 63,000. That's all.